Welcome back to my channel. We are continuing our sequence of integration, and today we are dealing with the following problem. As some of you may guess, we'll use integration by parts to solve this integral. And what we have here is ln x and x. It's obvious that we need to reduce ln function. So for this purpose, using integration by parts, we'll need to apply this method 3 times. Of course, we can directly go on and do this calculation, but it's repetitive and tedious, so we'll rather do the following approach. I'll introduce the in, which will be x times ln x to the power of n dx. And let's first calculate this. We'll use the integration by parts here. We'll take our function f prime as x and g as ln x to the power of n. Remember, in the end we should get fg minus integral of fg prime. Right, so let's do so. The integral of x is x to the x squared over 2, and we just simply rewrite ln x to the power of n, our g function, minus, we just repeat x squared over 2, and we differentiate ln x to the n with respect to x. A quick overview on how we should proceed with derivative of ln x to the n is, if you have composite function and we need its derivative with respect to x, it's n to the g of x to the power of n minus 1 multiplied by g prime x, right? So keep that in mind, and let's write. It will be n times ln x to the power of n minus 1, and we multiply this by derivative of ln x, which is 1 over x, and dx. So what we have in our hands is, let's write this, x squared ln x to the power of n over 2 minus, so let's just write n over 2 out of integral sign, since it's a constant, n over 2 integral of, now here x squared and x 1 over x cancels out, and we have x times ln x to the power of n minus 1 dx. So what is it in the end? Let's just write our function in. It'll be x squared ln x to the n over 2 minus n over 2 I of n minus 1. Right? Just look at this structure and how we defined our function in. So it's just I n minus 1. This is called reduction formula, and here we basically applied integration by parts once, and we won't need to apply it in each of our steps. So let's look at our initial integral. Our initial integral is, in terms of I, it's what? It's I3, right? So let's just find I3. Well, I3 equals to x squared ln x to the cube over 2 minus 3 over 2 I2. Now, what's I2? First, let's just repeat this, over 2 minus 3 over 2. Now, I2 is, again, we look back to this formula. I2 is x squared ln x squared over 2 minus 2 over 2 I1. Now, let's break this down. First, again, ln x cube over 2 minus, let's just multiply this because this is already known. It will be 3x squared ln x squared over 4 and plus 3 over 2 multiplied by I1. What's I1? Again, let's look at our formula. It's x squared ln x over 2 minus 1 over 2 I0. Now, let's break that down. We can just copy this to not lose too much of time. And also, as I did before, let's multiply this term. It will be 3 times x squared ln x over 4 minus 3 over 4. Now I0. I0 is, let's look how we defined our I in the first place. I0 will be integral of x only. Let me write it here for some of you who struggle to get this, because it's a little bit messy down there. X ln x to the power of 0 dx, which is x dx, right? And the value of which is x squared over 2 plus c. This is our I0. We keep that in mind and plug here. It will be x squared over 2 plus some arbitrary constant c. Let's do this c prime so that in the end we can use just c as our constant. It's a basic thing here. We multiply, we'll get the constant as minus 3 over 4 c prime, and we just want this to be equal to some other constant c, which won't change too much in our final answer. And our final answer, x squared ln x cubed over 2 minus 3 times x squared ln x squared over 4 plus 3x squared ln x over 4 minus 3x squared over 8 and plus some arbitrary constant c. As I said before, this minus 3 over 4 c prime is equal to c, but it's not that important. So let's just delete it and let's finalize our answer. Here it is. And here we are. We are done. If you have any questions, feel free to write them in the comment section below and I'll try to answer all of them. See you on the next videos.